Welcome to Probability Video 6.7, teams with members of two types. Here's example 7. A group of 12 consists of 5 boys and 7 girls. So those are the two types. I put boxes and stars by them. Those are the important things of the problem. 3 parts. And notice for the 3 parts, I've got some important vocabulary words underlined. Exactly, at least one, at most one. All right, let's step through these. Part A, how many 5-person teams contain exactly 3 boys and exactly 2 girls? All right, what we're going to do is the multiplication rule. The number of ways of doing event 1 times the number of ways of doing event 2. Event 1 is picking the boys, event 2 is picking the girls. Okay, so out of 5 boys, I want to pick exactly 3. 5, choose 3. For the girls, out of the 7 girls, choose exactly 2. All right, and if you work that out, this comes out to be 10 times 21, and you get 210 ways. Okay, part B. How many 5-person teams contain at least 1 boy? I'll show you the tedious way of doing this, and then I'll show you the better way. Here's the tedious way. If you've got at least 1 boy, that means you could have 1 boy, or 2 boys, or 3 boys, or 4 boys, or all 5 boys, with the associated number of girls along with that. So if you wanted to, you could say just like this. All right, out of the 5 boys, choose 1. Out of the 7 girls, choose 4. Add up. Out of the 5 boys, choose 2. Out of the 7 girls, choose 3. Add up. Out of the 5 boys, choose 3. Times of the 7 girls, choose 2, etc., etc. I don't even want to finish the example. All right? So let me show you the better way. Again, either it's going to rain or it's not going to rain. Either you'll have at least 1 boy or you won't have at least 1 boy. So for problems like this, I draw my total set diagram, and I break it up into those 2 parts. At least 1 boy or no boys. And the total, not worrying about boys and girls, is just that 12 people, choose 5 of them. That's the total. All right? And I want to find the at least 1 boy. Well, this, I don't want to have to add up. It's usually easier to add things up where none of them happen. So here we go. So if I got no boys, essentially that means I've got 0 boys and all 5 girls. So I've really got just 5 girls. So if you want to do it the same way, you could say, oh, out of the 5 boys, choose 0. Out of the 7 girls, choose 5. Now, of course, this is just the number 1. I could have just done it that way, but I'm just showing you the same template as above. So 7 choose 5 equals 21. All right, and then at least 1 boy, so at least 1 boy, once again, will be total minus no boys. Total minus no boys. All right, and the total was 12 choose 5, and the no boys was this, and 12 choose 5, we did that before, that came out to be 792. So this was 792 minus the no boys was 21, and we get 771. Much easier than adding all and multiplying all that stuff. All right, the final part. How many 5-person teams contain at most 1 boy? Okay, so there's a big difference between at least 1 and at most 1. At most 1 boy really means no boys or 1 boy. Okay, so this really means 0 boys or 1 boy. And if I got 0 boys, I've got 5 girls. And if I got 1 boy, I've got 4 girls, because it's a 5-person team. Okay, so now it's just like this problem, but just doing a couple more scenarios. So we'll pick the boys. Out of the 5 boys, choose 0 times out of the 7 girls, choose 5, or means plus, and means multiply. Over here, out of the 5 boys, choose 1, times out of the 7 girls, choose 4. And if you do the math, this is 1 times 21 plus, obviously that's 5 times 35. So it ends up being 21 plus 175, and we get a grand total of 196. So there you have it, how to find the number of teams with 2 different types, with exactly, at most, and at least.